Hi friends, very good morning to all of you. This semester I will teach you the subject Structural Design 1. Now, what is structural design? So in the last two semesters, you studied about structural analysis. That means theory of structures 1 and 2. In theory of structures 1 and 2, mainly we discussed about the actions on beams, mainly the shear force and bending moment on beams. So due to these actions on the beams, the shear force and bending moment, the corresponding bending stress and shear stresses are developed. So actually in structural design 1, we are going to learn about the design part. So according to the values we obtained from the analysis, how to design a structural member. So that is the main topic we are covering this semester. Now for this subject structural design, we need the standard codes, the Indian standard codes for the design. It is written on the right hand side, IS 456-2000. IS 875 and SP 16 for IS 456. So these are the relevant codes, the authorized handbook for the design. So when we design any structural member, we need the standard values obtained from these codes. So this is very important. So all of you should have these codes with you when we discuss the design of any structural member. Now today, I will give an introduction about the topics or all the modules what we are going to learn this semester. See, the first module, Introduction to Materials. So you already studied in construction management and engineering or construction materials and engineering about the different materials for concrete, PCC and RCC. And you know the difference between plain cement concrete and reinforced cement concrete. In concrete, the bending material, coarse aggregate, fine aggregate and water to be mixed to get the concrete. Similarly, in RCC, in addition to these ingredients, steel reinforcement is also embedded to take the tensile stresses. All these things we already studied. So that part will revise once again about the materials. Materials used for concrete, that means plain cement concrete and reinforced cement concrete. That is the first part of the first module. So that includes selection of materials for the concrete and how it is mixed and how it is transporting, about compaction, about curing. All these, the process to make the concrete, you will discuss in the first part, Introduction to Materials. And in the second part, concept and methods of RCC designs. So there are different methods to design an RCC member, in which the latest method or the revised method is known as the limit state method of design. So we will mainly focus on that. As per our syllabus, we will focus on limit state method of design of all RCC members. That will come under concept and method of RCC designs. So when we design any RCC member, we have to consider the three factors. First one, the strength. The second one, serviceability. And the third one, its stability. So whichever may be the structural member, may be a beam, a slab or a column. In all these structural members, we should see the strength, serviceability conditions and the stability conditions. So after designing, the first part of the design, the strength of the beam will be calculated. That means as per the loads comes over the beam or slab or column, we will analyze all the loads, and as per the loads we will find out from the codes, from the relevant codes, what I have told you earlier, we will find out the area of reinforcement required, the number of bars or the grade of steel to be embedded in RCC members. So that comes under in the concept and method of RCC design. In the first part, the strength of the strength part, and second part, serviceability, will check. After designing, we will check for the stiffness, that means mainly deflection and cracking, and its stability also. So therefore, a structural design means there should be a coordination between a structural engineer, that means a civil engineer, and an architect. So because in addition to these strength, serviceability and stability, we should see its aesthetic view and also the economic point of view. So for this, there should be a coordination between an architect and a civil engineer for the structural design. Okay. Now the second module. In the second module, design of flanged beams. The first part or first module we discuss about single reinforced beams, double reinforced beams, etc., and also the slabs. But in the second module, flanged beams, that means having T-beam and slab, that is a combination. We will discuss it about and check for shear, stiffness, etc., torsion and bond, the development length to be there in the respective structure. That comes under module 2. And module 3, design of one-way and two-way slabs. When we discuss about the slab, there are two types of slabs mainly, one-way and two-way slabs. Depending upon the dimensions of the slab, we can classify into one-way or two-way. That we will discuss in detail in module number 3 and how to design as per the codes IS 456 in the third module in detail. And in the fourth module, design of staircase, columns and footings. You already studied in your construction materials and engineering different type of staircases like dog-legged staircase, open well staircase, etc. So we will see that different staircases and how to find out the rise, tread, etc. and also the reinforcements to be provided in these staircases, and also columns and footings. You know the different type of columns, short, medium and long columns, and you know the slenderness ratio, how these columns are classified and how to find out the buckling load, etc. We already studied in our structural theory. And as per that structural theory, we will design the columns also considering the loads over the columns, whether it is eccentric loading or concentric loading, depending upon the nature of loading, we will design it. And the last one, footings. Footings also, you might have seen different footings, different type of footings for a building. It may be column footing, individual column footing, or combined column footing. For number of columns, a combined footing may be provided. So accordingly, we should design the column and footing based on the relevant codes IS 456 and IS 875 and SP 16 for IS 456. That IS 875 is mainly used for the loads, for considering the design loads for the structure. When we design it, how much load should be taken, that will comes under the category IS 875. So these are the 4 modules to be discussed in this semester. So next class onwards, we will start with the first module, Introduction to Materials and Concept and Methods of RCC Designs. So before that, all of you should have these codes and the reference books with you when I teach all these modules. Okay? Thank you one and all. We'll meet you again in the next class.